Okay, if you missed or I did not get through how to do this homework number five on the contract, I wanted to make sure you all understood how to do these different types of mathematical equations that deal with the gas relationships. So this one is on pressure and volume. So you take pressure times volume at this set of conditions, and then you take another set of pressure and volume at another set of conditions, and no matter whatever set you have it with this particular gas, you're going to have pressure times volume always equal another pressure times a volume. Okay, and when you do that, then you can always find the second volume or the second pressure. Okay, so let's look at this example. Remember that this is Boyle's law. This is Boyle's law. That's the name of it. You don't have to memorize a name to the equation. It is opposite effect. It's affecting each other oppositely, or it's in direct relationship. Okay, the temperature and moles are constant. So let's look at this first example. It says, what is the new volume? What is the new volume of a balloon that contains 30 liters? Okay, 30 liters, and has a pressure of 100 kPa after it's risen in the air to a new pressure of 25 kPa. Okay, so the goal is to figure out what are these numbers, what measurements do they go to, and so what you see here is that this first liter is a volume, and so you're going to make that your volume 1, and then you go through and you see the 100 kPa, that's going to equal your pressure 1, and then after you make this balloon rise in the air to a pressure, the pressure is going to be going down, and so the pressure is changing to 25 kPa. So as you're reading through the questions, you'll be doing this for all the assignment questions here on this homework, but you're going to be figuring out what is a volume, what is a pressure through the process. So this set of problems, you're going to have pressure 1 is going to be 100 kPa, okay, and then you're going to have volume 1, and that's going to be 30 liters. And then the next number is 25 kPa, and that is your second pressure. And then what you're looking for and what the question's about, the question's asking, what is the new volume? Okay, what is the new volume? And so that's what you're looking for. So you're going to be putting these numbers together, and so you're going to put your P1 first, 100 times kPa. You're going to times that by the 30 liters. You're going to set that equal to the 25 kPa times V2. And when you do this, you're going to go ahead and solve for V2 by dividing both sides by 25 kPa. And you'll find that these cancel out. And so you're going to do all this math here, 100 times kPa over 25 kPa, and it's going to be becoming 30, or excuse me, 3,000 over 25, and you do the math, it should come out to be 120 liters. Okay, that is your answer for V2. Okay, I just wanted to point out that you notice that the pressure from P1 to P2 is going down 4 times. And so you'll notice that the volume from 30 liters to 120 liters goes up 4 times. So the whole essence of indirect is that as pressure goes, when the pressure goes down, the volume goes up, and that's exactly what happened. 120 is greater than 30. Okay? So let's go on and do another example. I think this is where time ran out in class. Let's go through and then do the next type of problems. And we're going to use and do Charles' law, and this involves volume and temperature, and then volume 2 and temperature 2. Okay, you're going to do those in the problems on these next 3. Okay, so these 3, you're going to be looking for the values in the question. So this first one says a balloon has a temperature of 27 degrees Celsius and a volume of 4 liters. And so then what it asks is, what is the new volume at 57 degrees Celsius? So we have the 4 items where you're looking for volume 2. You don't know what that is, but let's put the other numbers in. So temperature 1 is 27 degrees Celsius. Temperature 2 is 57 degrees Celsius. And then volume 1 is 4 liters. Okay, so you're looking for those, noticing that this first temperature is 27, and the second temperature is 57, and you notice that the temperature is going up, so we expect the volume to also go up. Now the equation is going to be a little different than what we had earlier. You're going to divide the numbers, but you're going to put 4 on top and 27 on the bottom. But what's going to happen is you've got to actually have your temperature in actually at 273, because you got to be in Kelvin. Okay, so let's go ahead and do that first. We're going to take 27 degrees and add 273. We're going to add 57 degrees and add 273. And so now our new numbers, this equals 300, this equals 330. So we have to use these numbers instead of the 27 and the 57. Okay, so let's add those in. I'm going to go ahead and erase them and make them Kelvin, just to have them a little clear on the screen here. How we got the 300, we want to get this to 300. T1 is 300K, and T2 is, let's change this, 300K, and this is going to be 330K. Okay, so let's go ahead and follow the equation up here and take 4 liters and put that over 300 and set that equal to volume 2 that we don't know over 330. Okay, and when you do this, you're going to be cross multiplying here to solve. Cross multiply these like this, and when you do that, you're going to have 4 times 330 equals 4 times 330, and it equals 300 times V2, and that makes you then to divide both sides by 300 like this, and so then you cancel out the 300, and then this is the math that you're going to do to set up. And notice that your fraction of the 2 temperatures is going to make your 4 number go up. And so when you do the math, you're going to have the 4 times 330 equals 1320 divided by 300. And when you do that math, 1320 divided by 300, you should be getting a value of 4.4 liters. This is your answer for V2. Okay? The big difference here in these problems, to get the 4.4, you're noticing that the volume is increasing, which is what you expect. Okay, it is increasing here, and that's because there's a direct relationship. There's a direct relationship. Okay, so you always want to check. Do you see it going up? And you do. So you divide the numbers in these types of problems, and you want to also be in Kelvin. You got to be in Kelvin. So make sure you change 20 degrees on the next problem to Kelvin, and then on number 3, it's already in Kelvin. So when you do number 3, for instance, when you go down to number 3, you're going to be taking 4.3 divided by 350 and set that equal to a new volume at 250. Once you've done these problems many times, you'll begin to just setting it up and then go ahead and solve here. You guys can do the solving, but you're going to cross multiply and solve for V2 when you get to that answer. So since they're already in Kelvin, these are already in Kelvin, you don't have to do any addition. They're already set to go. You don't have to do anything else or special since they're already in Kelvin. Okay? Now let's go on to the Gay-Lussac law on the next page. Okay, and now it's very similar to the last one. Notice here that you are using a similar equation, P over T and over P2 over T2. So you're looking for pressures and temperatures. Okay, so on this first example, we are looking for a temperature, and we can go ahead and put it in Kelvin or keep it in Kelvin for the final answer. I'll probably list both in the key, but we can have a pressure of 75 and a pressure of 25. You can see how the pressures are changing, and now we're trying to look at what happens to the temperature. So let's write these in. We're going to have 75 kPa for your first pressure originally, and then in a temperature of 40, oh excuse me, I got this mixed up, let me go back here. We have a temperature of 45 degrees Celsius. We have a pressure of 75 kPa. Okay, we're looking for the new pressure, that's what new temperature. Okay, we don't know the new temperature. And then our second pressure is 2.5 kPa. Okay, so we're noticing that the pressure is going down, so we predict temperature will also go down. Okay, so let's see if that happens. Let's look at these also to tell if they are following what you predict. Okay, so we're predicting that temperature is going to go down. So let's put the numbers in. But first we got to add 273 to this one. And that is going to equal, I believe, 318 Kelvin. 318 Kelvin. Let me double check here. Yeah, 318 Kelvin. So let's go ahead and put the numbers in. We're going to put 75 on top because that's pressure. We're going to put 318 on the bottom. We're going to set that equal to 2.5 on the top, and the temperature down below, that's what we don't know. So we've got to cross multiply here and be very careful since temperature's on the bottom. I get a lot of students that get this wrong. So you want to make sure that you bring temperature up and put it beside the 75, and then you're going to take 318 times 2.5. Let's find out what that equals. 318 times 2.5, and that equals 795. So then you're going to get 75 kPa times T2 equals 795. We're going to divide both sides by 75. And you should be getting about 10.6 K, which is really cold. That's really cold. But when that pressure drops, you see how much the pressure is dropping? The temperature is also going to drop. So it did do that. It did go down really low, pretty low, all the way down to 10K, 10.6 K. So it really did go down. It did do what it was supposed to do. It did, and I missed the prediction, I'm sorry. So it did, we do predict that the temperature goes down. Now, one more equation to go through to help you. And if you already know what we're doing with all the equations, you could probably just stop here, but you can continue if you want. But you're going to have, note that in this equation, we've got PV and T involved, all three of them. Okay, so we're going to involve all three of them, and then you're going to have them all changing, so you can put P, V, and T are changing, but remember the N is staying constant. And so in these problems, you're going to be looking for what everything is, and you have a volume here, and you're going to have a temperature here, you're going to have a pressure. All three of these are involved with the similar conditions. And then the other conditions, the other new ones, you've got this new pressure and this new temperature. So the ones in green are your old ones, and the ones in yellow here are going to be your new conditions. Okay, so let's write those in. We've got a temperature of 31 degrees. We've got a pressure of 0.45 atm. And we've got a volume of 24.5 liters. And then as we go to the new conditions, they're asking for the new volume. That's what we don't know, the new volume. And the pressure is now 4.5 atm. And the temperature is 95 degrees. Okay, so just a reminder, you want to set up your temperatures to be in Kelvin. Okay, so these numbers are the following in Kelvin. This T1 is going to be 304 Kelvin. Okay, and then T2 is 368 Kelvin. It's really important that you get these in Kelvin. So you're going to put 0.45 atm times 24.5 and divide that by 304. And then we're going to set that equal to 4.5 atms times V2 over 368. And there's a lot of ways you can solve this. I tend to look at the entire side here. I tend to look at all of this. You know, we could also cross multiply, so I can follow that pattern. Since I was doing that earlier, you can cross multiply like this. And again, you guys are probably really savvy on solving yourself, not a problem. So if you want to stop the video, you can. But I'm going to continue so you guys have an answer here. 304, let me use the same color. We have 304 times 4.5, and that equals 1368. Okay, so I'm going to go ahead and erase these two. That's what the top is. Okay, so 1368 is the top. And then we're going to go ahead and set that equal to 0.45 times 24.5 times 368. And this is totally a final number. These two actually had the V2 with it. Okay, so I forgot to put the V2 with it. The V2 goes, these all go together here. These three all go together here. And I forgot to put the V2 there. So those two times together is the 1368. So you put V2 here, and then you have all these three numbers. So these three numbers, the 0.45, the 24.5, and you times it by 368 is going to equal 4,057.2. Okay, so all this is equaling to 4,057.2. So we have the 1368 V2 equals 4,057.2. So V2 equals 4,057.2 divided by 1368. And then what that equals is 2.96. And that's what your answer is in liters. Okay? you ultimately had the V2 equaling 2.96 liters. It's kind of hard to predict what will happen because everything's changing, but that's what your answer is for this first one. So now you guys can go ahead and continue with number 2 here. You guys can answer number 2. You can go back and do the top. This is the Gay-Lussac side, the Gay-Lussac laws here. You can do number 2 and do number 3. You can go back on the other pages with Charles Law and do 2, finish 3 here. And then also go to the very top and do Boyle's Law. Do Boyle's Law here and do number 2 and number 3. So let me know if you're needing help